Welcome to Dr. Yap Van Ha's Problem Box. In today's lesson, we are going to solve a problem. Let's see what problem we have for today. This is the problem I picked from Dr. Yap Van Ha's Problem Box. 72 students choose either baking or art or both baking and art. There are 48 students in the baking class and 39 students in the art class. The question is, how many students pick both baking and art? Here's the problem once again. So, who is in the story and what is it all about? 72 students. And it is about them choosing the baking class or the art class or both the baking class and the art class. There are 48 students in baking. Some of these 48 students are doing only baking, and some of them are doing baking on top of the art class. There are 39 students in the art class, and of the 39 students, some are doing only art, no baking. But some of them, they do art on top of the baking class. Our problem today is to find out how many of them are doing both baking and art. Why don't you give it a go? Let's try. Have you managed to solve the problem? Or how far are you in trying to solve that problem? The question is, how many students choose both baking and art? One possible method is to make a list and then guess how many of them choose only baking, how many of them choose both baking and art, and how many of them choose only art. I can guess and then check whether or not my guess is correct. Maybe there are 10 students who choose both baking and art. But we know that there are 48 students in the baking class. So there must be 38 of them who are doing baking but not art. Likewise, there are 39 students in the art class. So there must be 29 of them who choose to do art without baking. Am I correct? I am correct if the three numbers add up to 72, because in this problem, there are 72 students. Some of them doing only baking, some of them doing both baking and art, and the rest doing only art. So the question is, do the three numbers add up to 72? If they do, then I'm correct. But if they don't, I might have to come up with another possibility. I need to then guess again and check afterwards. If you like this method, why don't you give it a go? Another method is to use bar models. Let this represent the 48 students in baking and this, the 39 students in art. Some of the students who are doing baking, they do baking and they do not do art. Some of them do baking, but they also do art. And then some students do only art. So, students who are doing baking, students who are doing art. Some of them do both baking and art. Some of them do only baking, and some of them do only art. What do we know? We know that this number, those doing only baking, that number, those doing both, and this number, those doing only art, we know that the numbers add up to 72 because there are 72 students all together. We also know that that number is 48 and this number is 39. Remember that this group is actually this group. They are the same people. This number here and that number there. Would you like to continue with that method? Why don't you give it a go? Let's try. So, what's the answer to the question? How many students choose both baking and art? In other words, this number. So we know that is 48. We know that this is 39. And then we also know that this number, those doing only baking, the first group, together with the second group, those doing baking and art, and the third group, those who only pick art, they add up to all the students, which is 72. Can you think of an equation to solve the problem? Let's see what we can do. So do we know the total of this and that? 48 and 39? That's not too hard, isn't it? That gives us 87. So that's 87. And what we need to know is that value. You know, the one that stands for the group of students who have chosen both baking and art. So all that is 87. And we want to know the value of that. What can I do? I suppose I can get the value of that if I know this. Do I know the value of this? The first group of people who did only baking the second group who chose to do both, and the third group who have chosen to do only art. Do we know this number? That is right. This is 72. This represents all the students in the story. So if we know this is 72, and we knew that that's 87, and we want to know this value, can you see the equation that allow us to find this value? 87, and we know that is 72. Is that right? Can you write down that equation? I think you are right. The equation is the difference between 87 and 72, which really is 15. So this represents 15. So now we know there are 15 students who choose both baking and art. So, do you prefer the first method of making a list or the second method of using bar models? If you find today's lesson easy, you can challenge yourself. How can we challenge ourselves? One way is to find out more about this thing called Venn diagrams. Problems like the one we just solved can also be solved using Venn diagrams. Why don't you go and find out from the internet, from books, about Venn diagrams? Another way we can challenge ourselves is to solve a related problem. What if I let the rectangles represent the number of students in the two classes? And how many students there are in each class is represented by how big the rectangles are. So you can see one rectangle is larger than the other one. That's because there are more students in the baking class than in the art class. In fact, we know there are 48 students here and there are 39 students here. Let's challenge ourselves by solving this related problem. How big should this rectangle be? And how big should this rectangle be so that they accurately represent the numbers 48 and 39. But remember, 15 of them, 15 students chose both activities. So I need to overlap the rectangles, isn't it? I need to overlap the rectangles so that the amount of overlap shows 15 people. That's a challenge for you. Can you draw accurately two rectangles overlapping so that this represents 48, that represents 39, and the amount of overlap, however it can be done, represents 15. If you find today's lesson easy, that's another way to challenge yourself. See you in another problem box.
forget the day we met. Your eyes so blue, me piercing through. I can't forget the day we met. Your